Alright, let's begin. Is my mic on? Yes, it is. Is the music too loud? Yes, it is. Okay. Oh, actually, before we start, I do have a request from Hayes from last time, and I could see his name in chat, so I'm going to put that on right now. Which one is it, though? That's the thing. It's got to be that one, I think. Let's give it a bit of volume. There we go. So we've got here, hi Mr. G, hi Andy, hi Amok, Colt, Stepz, Hayes, Buzzley, hi guys. Let's get all my windows open in the right places. Oh. I don't know why, but it didn't show the request, so you got this one for free, I think. Put everything in a box, shake it, yeah. Sometimes it feels like that's the only way to fix these things. Alright, I'm going to drink some wine tonight because it's bloody roasting. We're on only 8.5 degrees in here. And I'm hoping this will help me get to sleep tonight, so tonight we're going to look at software sprites. Specifically, we're going to look at bullets. It's good, that wine as well. So software bullets is a pretty common use case in games. Speak as a type. Because obviously you only get 8 hardware sprites, and if you're doing a game with lots and lots of bullets, you don't want to use all those sprites up for doing bullets and even multiplexing. You're going to run out of sprites quickly unless you've got some crazy good multiplexer. So most people tend to go for software sprites. So what do I mean by software sprites? So software sprites is using either character mode or bitmap mode to generate movable objects on the screen. So yeah, as Hayes has very conveniently done with his emotes there, we have actually done them before. We did them in Luna, but it was probably done very quickly, and I didn't go over kind of exactly how that works. So just turn that down a bit. Is this still Lazy Jones? No. Okay. Let's go back to what I was on before, which I can't remember what I was on before. I think it was this. Yeah, it was this. Okay. So basically with software sprites, what you need to do is you need to create your own sprite registers. So you need to create some registers somewhere in memory, a block of memory somewhere that you're going to use to store to store the stats for each of the sprites. Now, obviously, doing things in char mode means that you have to make some concessions. The main one being whether or not you blend the background in or not. Now, I am going to go through how to blend the background in. But every time you do that, you take a significantly longer piece of time to do it. Yeah, there was. I put Lazy Jones on for you. Do you not hear it? God damn it. As someone who has done ST stuff, my question isn't there any other types of sprites. So one of the things I'm actually looking forward to on the Mega 65 is because of the speed. Doing software sprites should be relatively simple. It was the same technique as I'm going to show you now, but we'll be able to do 50 times as much per frame. So that should allow software sprites with background blending and very little overhead in terms of frame time. So I'm just going to create a simple setup here. So I'm just going to block out the kernel and the basic as I normally do and turn off the CI engine. So this is like my basic setup for every program that I ever do. God, what is this tune? Proof of Destruction. I don't remember that game. Okay, so we will have a loop here. For now, I'm just going to jump straight to the loop, and then we'll add some kind of timing in here as well. So let's have our software sprites down here. So generally, you want to kind of record an X position, a Y position, potentially a character that you want to use. You can either supply a color as well, and then there'll be some other data that we'll need as we merge it into the background. But some intro playing at the bottom for a long time. Can't see some intro playing at bottom for a long time. No, I'm not sure. Not sure what you mean by that. So in this smooth movement across the screen thing, I load POSX into the accumulator and check if branch of carry set, then turn on the high byte flag. But when I move left instead of right, it seems to make that check happen way too early. Okay, I mean that sprite positioning is something you should probably check out. Oh god, which one did we do it on? Try to think of a good stream for you to watch that has those stuff in. But I have kind of covered this in some streams before. Oh yeah, it's in the yeah, it will be in one of the PDFs because it's one of the early things we did with the player control. Yeah, so check out like number 2 or 3, I reckon. Probably has it in there. Yeah, the high bit is a pain in the ass. You have to deal with the high bit in a funky way. This is another reason software sprites is kind of nice now and again, because you don't have to deal with the high byte. So the most basic software sprite is just going to have an X and a Y, right? So let's call it soft sprite, and then that will be the kind of prefix for all our data. So we'll have soft sprite X, soft sprite Y, and these are just going to be tables of X and Y positions. I like to always create something like this just before the table, so I can just define how many software sprites I want to put in. I'm going to go for 32. I think that's a good number, and then that means here I can do this. So it just makes filling out these tables really easy. And then if I want more sprites, I just have to change this here, and it changes the numbers here. We can also use this value in loops later on. So this is the bare minimum we need to draw a sprite on the screen. Obviously, this doesn't have any definition of what we're drawing on screen. So another good thing to include in here would be soft sprite char. So which character number we want to put in there. Now for bullets, you're probably also going to want a direction X and a direction Y as well, or delta X, delta Y. And this will be the amount that every frame these sprites move. So the reason why software sprites work really well for bullets is because bullets move fast. So you don't need to draw anything in less than 8 pixel kind of divisions. So if you imagine a screen, and this is a row of characters here, and this is your bullet, it's really easy to move that bullet along just by moving it along one character at a time. It means it's moving 8 pixels at a time, but that's usually about the right speed for bullets anyway. So That's why it's a good system for bullets. I mean, a really good example of character software bullets done well is in Turrican. Although there are some bugs in Turrican, and I'll explain why they happen later on. You're the high bit. Yeah, you can. Yeah. Yeah, Andrew Braybook used them in Iridium as well. Actually, he did a really cool thing with the way he did them in Iridium by he did merge them into the background, but I'll show you some tricks for merging into the background with bullets in a minute as well. Hey Prince Phase, hey Dubster, welcome to the stream, dude. And hey Old School Coder as well, I missed you joining. Okay, so these are the properties we're going to populate for our sprites. So we're going to have an add software sprite, or we'll call it add bullet, I think. And this function is basically going to take an X and a Y and a character and make it appear on screen. And then what we'll do is so this is going to take accumulator as the char, X equals X position, Y equals Y position. And then it will return an index into this, so we can set other properties such as the delta X and the delta Y. So the other thing we kind of need here as well is soft sprite, next soft sprite. And the next soft sprite basically just tells us which is the next software sprite to use. This will be incremented every time we add a sprite, and once it gets to the number, once it reaches this, it will just loop back around. What that means is that if we reach the limit while there are still software sprites on screen, then the previous one is going to end up being overwritten by this one. And this is one of the problems I think Turrican has, is that it uses a system like this, but occasionally you can have so much going on screen with software sprites that you hit that limit, and when the next bullet is drawn, it basically freezes the last one in place, and that last one basically stays there. But I also think there's another issue that they have with double buffering, which I'll explain when we get to that. So, yeah, software sprites today, Prince Phase. So if you want to move by less than one char, you need many chars for intermediate positions. Yes. So doing it this way, whenever we move a software sprite, the resulting sprite will always be drawn in a single character block. You'll never be drawing a character that isn't in a single character block. If you want to move the sprite in less than one character increments, then you need to start using 2 character blocks to draw it. So you basically split the sprite into 2 halves. One half is drawn on the left, one half is drawn on the right. If you've got vertical movement as well, then that would be 4, and it would be in quarters. Which is what we do in the Saturday game. In the Saturday game, there's we have 32 predefined 32 predefined kind of blocks of 2x2 characters, which we use to draw into the map. Although I'm going to reduce that down to 16, which I'll explain at the weekend, just to save a bit of space, because it does use quite a bit of space to do that. Well, if you think about it, 32 positions of a sprite will take 32 bytes each. So that is 1000. So it's a whole kilobyte that's used just to store the graphical data for that bullet. So I'm going to reduce that by half, which will free up about 512 bytes. Because there's no reason for it to be twice the resolution vertically as it is horizontally, which is what it is at the moment. Okay, so let's add a sprite on the screen. We're gonna add some screen clearing routines and stuff in here soon, and then at some point we'll add a background in, and I'll show you how it works from a background as well. Okay, so I'm going to start by I'm going to store the Y value in a temporary location. So I'm just going to make some 0 page labels up here. Actually, I can do it. I can do it here. Virtual. So, as I explained in the last stream, virtual just means that anything following this until the next kind of star, which this is basically doing for us, won't actually be written into our PRG. We're just assigning these variables up front so we can use them. These values won't be written into memory though. Right. So the reason I need to store that is because I need to grab the index. So I need to grab this next software sprite. So I'm going to load that from here. And then I'm going to store accumulator at, which is our character. So that's at software sprite char, comma y. And then I can store x at software sprite x, comma y. And then I can load the value in temp again. That goes into software sprite y. So now I've got all these values here filled in, but I haven't got these filled in. Now these we probably want to define when we add the bullet, but obviously we've not got enough parameters to pass these in here. So one way we can do this is we can push these values onto the stack and then use some stack manipulation to pop those values off. But when you jump to a subroutine, you're going to get the return address popped on as well. So you'd have to pop that off, pop the values, and it just starts getting messy and slow. So what I like to do is I like to just return the index here. So y is our index, but what we're also going to do is we're going to we'll transfer that to the accumulator, and that's what's going to get returned. Actually, no, we'll return it. We will return it in y. We'll keep that. But what we'll do is we'll transfer it to x, and we'll also do this. We need to increase it and compare it to maximum soft sprite. So what this is doing is just making sure that when we return the index of the one we've just changed, but we need to set what the next index is going to be. This one here. So we transfer it into X register. We increase it. Turn that down. That's really loud. Hey Furrow, welcome to the stream, dude. Still really loud from that. Yeah, so we're going to increase this value in X, which is just a copy of the index that we had. We're going to compare it against the maximum number of sprites. If we hit the maximum number, we just reset to 0. Then we store that back in next soft sprite. And then we can RTS here. When we RTS, the Y register will contain the DX and DY. So that's how we add a bullet. But now we need to draw a bullet. And we'll go through draw bullets, so we'll do this in plural. So the way I like to do this, I like to go backwards through the loop. So I have to start with max soft sprites -1 because the maximum is going to be 31, not 32. We're going to loop here, and then here we're going to have a skip because we might want the skip drawing a sprite if it's not active. So that's our loop. So how do we know if it's active? So what I like to do is I like to use either the X or the Y or both of them. One is fine though, and just check if it's negative. So we will actually fill X with FF to say, and Y with FF to say that they're not active. Because if a value is FF, then it's off screen, we're not going to see it. So we'll load the accumulator with soft sprite X, Y, and if that's minus, or if it's FF, then we'll jump to skip. It means we don't need to actually draw that sprite. However, if it is Actually, we'll do it on the Y. I'll show you why in a second. We don't need to draw it if it's not being shown. However, if it is being shown, we then need to look this up. We need to look up a screen address and draw it for the screen. So there's two ways you can do this. You can either use X and Y like this. In fact, we'll do it this way first, because I think this is going to be the simplest way. But if I've got time, I'll show you some optimizations, how to change the X and Y into something a bit more useful. It's really, really warm. It's ridiculous. In fact, it's getting warmer. How is it getting warmer? It's getting later. My aircon is on full as well. Stupid. Stupid, stupid weather. Well, my little smoke inhaler's gone, but it's gone. Yeah. Whatever, I'll suffer through. Yeah, it's a delicate balance. I can't seem to win with the audio. For a start, the different SIDs seem to be at different volumes, which is really frustrating. But then different people seem to hear the music louder than others. So there'll be people who say I can't hear any audio, and then others will say I can hear it fine. And I'm always trying to make sure that my voice is easily heard over the music. So it's a tricky one. What I'd really like for, and I know Twitch will never do it, but and you know how you can set the different channels, audio channels in OBS? It would be nice if the user had different volumes where they could actually play around with those volumes. So I could set music to channel 1, voice to channel 2, and you could just switch. You could actually have 2 volume controls. I mean, but then I guess it's more bandwidth for them, and they probably don't want that. So, okay. So we're skipping the bullets that are not to be drawn, and now we need to draw the ones that are visible. So we're going to start by creating a table here. We'll call it a screen row. Actually, let's do it. Screen row LSB and screen row MFB. So you've probably seen this before in most of the things that I do. This is just a way of creating a lookup for rows in the screen. I'm going to create a screen ramp here, which for now I'm just going to set to 0400 because that's where we're at. But I will change this at some point, I think. It's worth noting as well that this is going to be a less than optimal version, but if I've got time, I'll show you some ways that you can use one of the indexing modes that's rarely used, actually, 0-page indirect indexing with the X register. You can use that to speed this up quite a bit. I'll show you how to do that if we've got time towards the end. It's not a huge modification, but it does make a difference. And it means you don't need, well, you do need these tables, but you don't need to look things up in these tables every time you draw the bullets. You only look them up when you add a bullet, and that's it. Okay, so we need to fill these. So these are just the rows. These are the rows that point to the screen RAM. So this is screen RAM was 28 times I, so that's the beginning of each row. And we're just looking for the LSB, so less than sign here. I'm going to stick it in square brackets so we can just guarantee that all runs before the nibble grab thing, but I think it does anyway. Not the nibble grab, the upper or lower byte. Yeah, 0-page index using X is something you can use. So one of the other techniques that you can use for this as well, and again, I'll show you that when we get to it. And in fact, I think we use it in the Saturday game, is to stagger the updates of these as well. Oh, you're making notes. Okay, I will obviously share this code when it's finished as well. And if anybody has got any questions about it, please feel free to ask me after the stream. Well, maybe not after the stream because it'll be late. But you know, you can ask on Discord, and either myself or somebody else can help you with these things. Okay. So these are the addresses that we're gonna use. Now I'm going to create a lookup here. Shall we put this together like this? Let's make that word. Oops. The reason I want to do this is I want to use the 0-page indexing to do this. So in fact, I'm going to change this to X because I don't want to use X register here. I want to use Y. Okay, so the accumulator now contains the Y position down the screen. So I'm going to transfer that into the Y register, and then I'm going to look up screen row LSB, Y, store that at screen lookup. I think as soon as we get this drawing multiple things on screen, I'll show you the X optimization. It does take a fair chunk of 0-page, so you have to make sure you've got enough room in 0-page to do it. But it will greatly speed this stuff up here, which I'll show with the border how long it takes, and we'll do a comparison before and after. So we're going to store that at screen lookup +0, it's the MSB, and then we're going to get the it is the LSB, and we're going to get the MSB, and we'll store that at 1, like so. Now we have the screen lookup. And then we can load the accumulator with our Sprite X, X, yeah. I think we can do load Y, X, so we'll just do that directly. Because with this is going to be our offset from the screen lookup. So the screen lookup is just going to give us the column 0 down the entire screen, but we need to know how far across the screen as well. So we'll store that in the Y register, and then we'll load the Sprite char into the accumulator. So now in the accumulator, we've got the character we need to draw, and in our Y register, we have its X position across the screen, and this value, this word in 0-page contains the screen lookup address. So all we need to do now is do store accumulator screen lookup, Y, and that's drawing the bullet. So this is enough now to actually display some stuff on screen. So what I'm going to do is I'm going to call draw bullets here every frame, and we'll just add some bullets here. So what we've got, we need to set a character. So we'll set the character. What's the little ball character? Actually, we'll just use the @ symbol. So we'll set the value 0, and we'll set that at 10 across and 10 down. Say. This does return an index, but we're not going to use it yet because we're not doing any update. But if we wanted to set the DX and the DY, we could do it straight after here. But I'm gonna show it with 1 bullet first. Okay, store X, Y does not work. Where is that? Should have known that. Oh, okay, so I need to transfer X to the accumulator. I hate this. They have a load X, Y, but they don't have a store X, Y. Go figure, makes no sense. Okay, so really simple. All we've just done is just drawn this on the screen here. But this is being updated every frame. So if we were to move this across the screen now, we would see it fill up all the way across until it no longer draws when it gets around to FF again. But we can add multiple of these. So let's add 2 in, and then we'll add some direction stuff into them as well. And you can see we can change the thing. So if I do an inverse of that things at 80, and I put it just underneath, let's put it here. You know that trick? Well, the zero page stuff. Actually, no, it was doing. Weirdly, it was doing the stars in Luna. So doing the star field in the background in Luna, I decided that it needed to be sped up a little bit, and I used zero page to do that, and that particular addressing mode was perfect for it. So there you go. We've got two sprites. They're just characters, but we do have technically sprites on screen. So obviously this is going to be a problem if we move them, right? So if we move these sprites now, so let's create another routine. Let's actually set the direction X on it. So we have in our Y register the index. So what we'll do is we will just set the horizontal direction to soft sprite dx, y. So that's now setting the horizontal speed to one of these bullets here. Likewise, I'm just going to put a little check in here for the. I hate doing it like this because it's never quite accurate, but you tend to get a glitchy frame every now and again. But it's good enough for this for now, and then I'll add a proper IOQ in at some point. And we will increase the border and decrease the border. So this is the actual code that's running once per frame, and then these are just some border stuff. So you can see it is taking quite a few lines to draw these two things, and the reason it's taking that time is because of this loop here. We are still having to test all 32 sprites. So if we reduce the number of those sprites, so we're only showing 2, right? So if we reduce the number to 2, we should see that sprite time drop a little bit, and it does drop quite a lot. But I think 32 you can get away with, and as we move on, you'll see it doesn't grow too much, but it is obviously going to grow for every sprite you add in there. Okay, so this is happening once a frame. It's happening, the code's happening here, and we see the stuff on here. So let's do an update sprites now. Let's call it update bullets. This tune's weird. What's this? Skate or Die. Cool. Oh, I watched your interview with. I missed the first part of it, and I watched it back today with Amiga Bill Hayes. Very good, and thanks for the name drop as well. Kind of cool. And I say that because I remember him talking about Skate or Die. It's kind of cool. Brain filled with pseudo Z80. Yeah. Game Boy Z80 is the worst. It really is the worst. It doesn't help that the hardware is terrible as well. Just kind of working out how to do certain things, like having to create a shadow copy of the screen to be able to read things on the screen. Although saying that, there's probably going to be something similar in this in a minute. So. Glad you was the music is playing. Oh, he did play it in the end as well. I watched your interview. I watched him play a bit of your game, and then I kind of had to do some work, so I had to stop watching. Stupid work getting in the way of things. How dare it? Apparently, it pays the bills. Why is too long? Oh, glad you told us. Can you seriously not hear that? I'll turn it up a little bit. Okay, I'm going to get people complaining now it's too loud, so just so you know. So update the bullets. So this is basically the same routine here. It's the same update. We need to go backwards through. Hey Andira, C64, welcome to the stream again, dude. Good to see you, man. And greetings from London. So pretty much we're going to do the loop again. So obviously this is going to take the same amount of time again. But what we need to do now is we just need to, for every sprite that's active, I'm going to indent stuff that's active like that. For every sprite that is active, we just need to update the values according to the DX and the DY. So for now, I'm just going to implement the DX. We'll worry about the DY later. So we need to take the value of the software sprite X, comma X. And then we need to add the value that's in software sprite DX, comma X. Now we're doing no bounds checking at all here. All we're doing is we're just making sure that the sprite. So it's cheers. Oops, let me get my. See, this is what I mean. The sounds are all over the place. Just turn that one down a bit. Can't win, can I? Hey, cheers. Oh my god. Thank you for the raid, cheers. Thanks to everyone that's come along with cheers. I would ask you what you're playing, but I saw you playing it for most of the night. How did it go? Did you manage to complete it? So Chiz is another C64 streamer who was playing Rescuing Orc tonight. Thank you for the follow, Bud100 or Budloo. Trolling streamers about sound. Yeah, I really wish they would add multiple volume controls in so you can control your own fucking music. Sorry. Okay. So no bounds checks here. We're just taking the sprite position, we're adding our offset and storing it again. You actually be disappointed if you finish the game in a 3 to 4 hour stream. Well, I mean, I don't know. Well, I mean, I was going to say it took me 3 hours to complete Florican on stream. I know I can do it in an hour and a half if I play it well. But saying that, to get to the level where I know the levels well enough to do that took way more than 3 hours. So it's not like the first time I loaded that game up, I completed it at all. It took many times to get through it. Thanks for the follow, Ray78. Welcome to the stream, dude. Alright, let's give this a try. So what we should see now is these sprites kind of fill the screen up with a line quite quickly. And you can see they're moving down the screen. So the reason they're moving down the screen as well is because we're doing no bounds checking. So when these sprites hit column 40, the actual offset that it's doing is just putting it on the next row. So what we need to do is we need to make sure that when it goes off the screen, it gets removed, basically. But before we do that, you can see another problem, and that is that the software sprites are leaving trails. So what we need to do before we draw a sprite is we need to clear the previous sprite. And so we have another routine, which is basically the same as draw bullets, but it's clear bullets. And this will go through and it will clear any existing bullets that are on the screen before we do an update, and then we draw. So clear, we will, for now we're just going to clear with the space character, but you'll see why we need to do a bit more than that at some point. I don't know what just beeped on me then, but something beeped on me. I have no idea. Oh, it's Akmafin telling someone the stream was going. Oh, and Romy's here as well. Hey, Miss Romeo, welcome to the stream. Thanks for the follow, Palcat. Welcome to the stream. Cool. I had a present for you to show on stream. Okay, it was a pineapple you bought a few days ago. Wait, a real pineapple or like a... Yeah. Oh god, so many follows. Jelly be good, thank you for the follow. So the clear bullets routine is basically doing exactly the same as the draw bullets routine, but it's going to draw a blank behind it. So we're going to combine all these into one in a minute, but the reason I want to do it separately is because I want to show you exactly how these things the order that these things need to happen. It might seem obvious to some people, but I've seen plenty of people get this the wrong way around and wonder why it doesn't do things. I mean, even now I'm doing it the wrong way around. So basically you need to clear the bullets. So you need to go and make sure that all the bullets that you can draw are being cleared on screen. Then you need to update the bullets positions. Then you need to draw the bullets. So if I do that now, you should see we now have things moving across the screen, and they're not leaving trails behind anymore. However, what they are leaving behind is space all the time, regardless of what they move over. So this is where the next thing comes in. So what we're going to do, we're going to fill the screen with something other than spaces. We'll fill it with the alphabet. Actually, we'll go through the font set, and we'll fill the screen with that, and then you'll see how we have to kind of deal with that. And then we'll go do some optimization. I'm not seeing anything when you post that Acmafin. It's all going wrong. Thank you for the host hitter, Sin there. It's all going wrong for you, Acmafin. Don't know what's going on there. Okay, so let's have a look. So we'll just stick a little routine in the top here.
Thanks for covering soft sprites.
No problem at all. Thank you very much for the bits that Amma. 1,000 bits, very generous of you. That's another bottle of wine for Saturday. Thank you very much. So we'll just create a routine. We'll call it full screen. This is just a little dummy routine. This could be anything. We'll be replacing this in a minute with an actual background, so you can see how we would do the actual merging. So what I'm going to do is I'm going to transfer X to the accumulator, and I'm going to store that at screen RAM. And I'm going to do this in rows. So I know it looks stupid, but you'll see why I'm doing that in a minute. Oh my god. Thanks for the follows.
If you're displaying enough sprites on screen, the number you need to display is 5555555.
Oh shit, he's figured out how to get it.
555555555.
Oh my god, I need to set an anti-spam up for Hayes. I'll thank you guys in a minute when this stops.
5555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555555 555.
Thank you for the follows, Skaslin, Nukem82, and Alrisu. And thank you for the bits, Hayes. I'm definitely going to have to set up some kind of anti-spam just for you. I think that's like the first time that's worked for you, because I think you've tried that about 5 or 6 times, and it's always just said 3 5s and then gives up. So well done on finally getting through the filter. Sooner or later, developing a new chatbot, what you want to do is making it haze proof. But yeah, 1 to 2 days. I think you need like a good week or 2. Thanks for the gift sub, Amma, and 5 months for Acmafin. Awesome. 5. Okay. So this is just going to fill the screen with garbage. It's basically going to be the entire font just drawn up front, and you'll see the problem we've now got with the sprites. So as you can see, the sprites are leaving a space behind them, and that's because we're drawing the sprites, but we're not making a note of what's actually underneath the sprite when we do it. So what we need to do is we need to add another value in here. So we've got the char that we had, and I'm going to put original char here. And this is just going to contain the thing that's underneath the sprite. So just before we draw it, we're going to grab what's underneath it. And so we're going to do that by... actually, we'll do the... I think we'll do some optimization now. I think we can probably get away with it now. It's starting to feel like we should probably do it. Oh, God, the wine's making me burp. God damn it. Pardon me. Actually, no. Let's go ahead and start this, and then we can optimize it in a minute. Let's just get it moving properly, and then we can optimize it. So, if you look what we're doing in here, we clear the bullets, we update the bullets, and we draw the bullets. So when we clear the bullets, that's when we need to grab the original char. So that is this one here. So at the moment we're just loading this value in. Instead, what we need to do is we need to load soft sprite original char commit and store that in the location. Right, so now the problem is this is the first thing that's going to happen. The clear sprites is the very first thing that happens. And as you can see, it happens before we update or before we draw. So we're going to have to grab that value right away, right at the beginning. So the way we can do that is by doing our screen lookup stuff again when we add the bullets, which is going to be here. So for Y to accumulator. Okay, so now Y, yeah. Oh my God, I'm going to do this. Actually, so this is why I want to optimize. I'm going to leave it as it is for now. It just means the very first position will be left with a blank or something that's not quite correct, but we'll correct it when we do the optimization. So we're going to grab this value. We need to fill this value in whenever we draw a sprite. So just before we do this and we store the value here, what we need to do first is we need to load the value from that position. Here, and store that in soft sprite original char from X, and then we can go ahead and we can. So we hang on. So store original raw view, and then in the clear routine. As I said here, we're just restore original. So clearing isn't clearing as such, it's just putting back what was there before. And there we go. You can see now as they move, they're moving over the background, and they're not leaving any junk behind. So we do have a bit of junk here. I think this is where the sprite started. And this is just because the very first time it does it, it doesn't do the clear sprite. So we can get around this actually if we just did draw bullets first up here. That will force recording the original char. So that should get rid of those two little @ symbols that we see. So you can see them here at the moment. So next to the Y of this position where they start. You see they're gone now. So the next thing to do is make sure that when they go off the screen that they get removed as well. So let's do that. Let's just check when they go off screen that they get removed. And then we'll just see it happen once, and then it won't happen again. So, and then I'm going to go for a smoke after that. So, let's drink some more wine. Get the liquid logic going. Okay. So, here. So this is where we update the sprite, and this is where we store our value here. So all we need to do is when we've calculated the value, we need to compare this value. So normally we're going to compare both the right side of the screen and the left side of the screen if you want sprites going in both directions. But for now, we're just going to check one side of the screen. So we're going to check that it's hit the value 40, which is the very next column after it's gone off the screen. So it would be actually the first column on the next row. And we use branch if carry clear, meaning is it less than this? In which case we'll jump to here and we'll just store that value. Otherwise, we're just going to put the value FF into the X register. And then we check in the X, now we're checking the Y, so we need to store it in the Y register as well. So there you go. So by storing that value in the Y register, we stop that sprite from updating. So what we should see now is the two dots go across the screen, and then when they go off the screen, they'll not update anymore. And there we go. They've gone off the screen. They've stopped updating. So now what we can do, we can actually create a bullet stream. So if we put a timer in here, so this is another trick that we use quite a lot. Actually, I'm going to go for a smoke, and then we'll add a bullet stream in. So pity the fool. I pity the. Oh my God, that can fin, seriously. Oh, lots of new people joined. Hey, Stackbats, welcome to the stream. Oh no, just Stackbats. I think, anyway. Struggling to keep up. All right, I'm going to take a quick break, guys. I'll be 2 or 3 minutes. I'll be as quick as I can. All right, be right back. And I'm back. Just a reminder as well, guys, we're going to play Tempest on the Jaguar on Saturday. I'm really looking forward to that. I haven't tested it out yet, so fingers crossed it works. But it's going to be pretty awesome, I think. It's the whole reason I bought the Jaguars, for that one game. So really looking forward to that. And if Flashback comes before the weekend, we might give Flashback a go as well. But I doubt it. Probably just going to play a little bit of Tempest for a few hours. That'll be after the stream on Saturday, not during the stream. Not during the code stream, obviously, but after the code stream. Okay, so what I'm going to do, I'm going to use this timer the same way I normally do. I'm just going to increment it here, and I'm going to use this to decide whether or not I need to update. I need to add another bullet or not. So I'm going to remove this, and I'm going to put this into. I'm going to call it shoot. And this is what's going to add the 2 bullets that we need on screen at this position. And what I'm going to do is I'm going to load the timer. I'm going to do it every 4th frame. Oops. Thanks for the follow, Nasty Bruises. I like that. I thought it's not 64-bit. I don't care what they say. It's not 64-bit. I think it has 2 32-bit processors, so they called it 64-bit, and it's really not. And in fact, it does. If you compare it to like the Mega Drive 32X, I think it was the weird kind of bolt-on thing that went on the top. The 32X was better than it. And they didn't claim to be anything other than 32-bit. But if you look at like Virtual Racer and stuff, so you can see now we've got a stream of bullets coming out of here. So now what I'm going to do is I'm going to change this this Y position. I'm going to make it move up and down, and you'll see we'll create a little sine wave. So if I just slow it down, you can see what's going on. We're creating a stream of bullets going across the screen. And so now we're drawing quite a few, and the border color is kind of using quite a bit more. So let's just expand the borders so you can see. I know this plays havoc with some people's OCD, but because of the fact that it shows this massive left border. But you can see we're still, still not bad, and we're controlling probably about 14 sprites, I'd say, and a maximum 12 to 14 sprites are going on here. But you can see how this would translate into kind of fast firing bullets on a system. So we're going to make this move up and down, and then once we've got this moving up and down, I'm going to tell you some kind of downsides of doing it the way we're doing it. Some things to watch out for, some techniques to get around that, then we'll try and do some optimization to move it into 0k to try and shrink this down a little bit. Oh my god. Well, that's actually not a bad joke though. I mean, Acmefin would kill to come up with jokes like that. Stack bats. That's very good. Why are panthers so much stealthier than jaguars and leopards? Because they have never been spotted. Very good. Yeah. No, well, that's much better than the crap that Acmefin comes out with, so it's fine. So I'm going to create a little table. Actually, I'd say little. I'm going to make it quite big. Actually, I'm just going to use the value in timer to set this. It is ANDed by 3, so that means if I do a table that's 64 long, I do it here. So I'm just going to call it sinus, and I'm going to fill this with 64 values, and they are going to be sine values that go from so I divided by 64 times pi times 2. I think that gives us the full sine wave. I'm sure that will happen first, but I'm going to do that anyway. And then I'm going to multiply that by 12, and I'm going to add 12. Actually, I'm going to multiply it by 10 and add 12. And then in here, what I'm going to do for this y value here, I am going to use the temp value to do this. So first of all, I'm going to load accumulator with the value in timer. I'm going to shift it to the right twice. That's going to divide it by 4. I'm going to transfer that into a Y register. I'm going to load accumulator with sinus, comma Y, and store that in temp. And then here I'm going to load temp. And then down here I'm going to do the same again. I'm just going to increase temp twice. I mean, this is really just God's sake, I can't remember how to. There we go. Have I got a? Yeah, I thought so. This is really just to kind of show that we can move these bullets around. I mean, you wouldn't do something like this in a game. You'd have player control this. There you go. You can see it kind of moving up and down there. And you can see how it's actually it's not doing quite the right thing. It is actually causing problems as it moves up and down. So the initial character is wrong for some reason. So we'll try and fix that in a second. I'm going to move it over to this side of the screen, to the first column. So I'm going to do that here, this column, and I'm going to increase this so that it waves a bit quicker. Okay, so the reason it's making a mistake down here is because what it should do before anything else is it should just draw those bullets once. So whenever we do a shoot, we're just going to call draw bullets. But I'll fix this in a minute when we do the optimization. But this should just get rid of that problem that we've got there. No, actually, it's made more of a mess of it than anything else. Oh, because I'm doing that in the wrong place, that's why. This should be in the shoot routine. Which is... Where's the shoot routine? Here it is. So, and now you can see that the bullets aren't destroying this side of the screen at all. So the reason we're never seeing them drawn in this column is because the first thing it does is it clears this column and then moves them onto the next column. Actually, we are seeing issues partway across the screen in certain places. Which I'm not entirely sure why it's doing that, because it shouldn't be. Let's do the optimization, and then I can show you how this is done much quicker and smoother. So the optimization is basically using zero page to store the positions. So what I'm going to do is I'm going to create a label. I'm going to call it soft sprite lookups, and then I'm going to move my map soft sprite up to the top. I'm going to keep my labels up here so they can be seen. The reason I move it to the top is if I don't, it will get confused as to where it actually lives. Sorry, not get confused where it is, but it won't be able to read that value until it's gone past it. So, and I'm going to fill this with max soft sprites times 2, and just fill it with 0. So what I'm going to do here is now when we actually add a sprite, it's when we add it, it's going to do the screen lookup. So here is where we add the bullet, and basically we just set the X and the Y. But what I'm going to do is, instead of setting this X and the Y, so I'm going to get rid of those. Instead of setting those, what I'm going to do is I'm going to use the X and the Y to look up the values that I need from this screen row table. So same as I do here, basically. And we're going to store that. So the way this is going to work is, first of all, I'm storing the Y here. Okay, don't need to do that, so let's just get rid of that for now. We do need to do that because we do need to set the character first. So we do need to set the character. Then once the character is set, then we can start looking at the screen position. So what we do is we load Y with temp again. Actually, we'll store X as well. We'll call it temp 2. Okay, so we've got X and we've got Y stored. And now what I'm going to do is I'm going to use X instead here. And I'm going to load the accumulator with temp, but I'm going to double it. So I'm going to shift it to the left and transfer that to the right. And the reason I'm going to double it is because each of these screen addresses takes 2 bytes. So each index is 2 along. Yeah. You're not a stand-up comedian, you're a shit-down comedian, that's true. Choosing names suck. Thanks for the follow, choosing names suck. Welcome to the stream, dude. So we're going to load the LSB. We're going to store it at this location here. It's at this location. It's now going to be this. And it's going to be comma Y. And that's going to give us the start position of the screen row for that sprite. But now what we can do is we're going to add the X position on as well. So the X position is currently stored in temp 2. So what we can do is, before we store it here, if we just clear the carry bit, add temp 2, and then here we just need to make sure we add 0 so we get any carry. So now sprite lookup actually contains the exact position on screen where that sprite should be drawn, which means we don't need to do any of that at all. We do need to grab the Y position, sorry, the index again. Where's the index? It's currently this one here, soft sprite. Yeah, we'll do that. We'll do it like that. Keep it the same. Why not? And so we're adding the bullet in the same way, but instead of an X and a Y now, we have an actual screen location. Did I shave? No. Keep up with the new generation, they'll take your job. It's got a point, choosing names sucks. The most difficult problem is coding what to name a variable. Yeah, it is. It really is. Okay, cool. Right, so add bullet is now actually setting these values here, but it's also setting these values in zero page. And this is why I said you need to make sure you've got space. So we're using 32 soft sprites, which means we need 64 bytes in zero page to do this. So we're using a quarter of zero page to do this. But the payoff is worth it, I think, because the speed of this will be so much better. So that's the add bullet. So that means when we draw the bullet, instead of doing this, what we can now do, and instead of doing that, what I like to do here, and this is where I need to switch this around again. So I'm going to change this to the Y register. So we're going to do this loop using the Y register, which is this bit here and this bit here. We're going to change these. You'll see why that's going to be different. We're now going to check something different. So we're going to check, probably we'll check soft sprite char. So if the char is well, we'll do 0, and we'll change what the actual char is like, because at the moment we're using sprite 0 in here. So I'm going to change these to, so it's just 2 letter A's sprinting across the screen. So the check we're going to do is just for soft sprite char instead. And this time we're going to say if it's equal to 0, then we're going to skip. So if the char is 0, it means it's not active, and we'll skip it. Otherwise, we're going to load a value from the screen lookup and store it, and then store our sprite at the screen lookup. Now, the easiest way to do this is, first of all, do the loop forwards. It's just going to be a bit easier to handle. So start with 0 and have 2 loops going, so two counters going. So this one is the check that we're going to actually do. So we're going to compare if that has reached the max soft sprites. Actually, if not, we'll call back to the loop. But at the same time, we're going to increment x by 2. And the reason we're going to do that is because we're going to use that to do this 0 page lookup here. So this is what the 0 page lookups for x looks like for x. It's inside the brackets. You don't do it inside the brackets, it will not be doing a 0 page lookup. It will just be doing a straightforward index, and it will be wrong. So this needs to be soft sprite lookups, x. So what this is doing, this is going to grab, starting at 0, it's going to grab the first word in this list, and it's going to use that, it's going to add, sorry, it's going to, where's it gone? There it is. It's going to take that address of that lookup list, and it's going to add x to it. So if the address is at 10, we're on sprite 0, it will look up the address that's found in the position 10. So address 10 and 11, just use those 2 bytes to form an address. When x becomes 2, it's going to look at 12 and 13, 14 and 15, 16 and 17, and so on. And this should be a lot quicker. As you can see, it's not doing half as much stuff now when it draws the bullets. In fact, it's doing a lot less, because now all we're doing now is we're just doing a simple lookup and a simple lookup here. And same goes for the clear bullets. We just need to do the same thing in here. So I'm going to change this again to do the same thing. So this is going to be 0 here. This is going to be 0 here. We're going to look at soft sprite char, y here. And we're going to branch it's equal to 0, because if the char is 0, then we don't need to do anything. And then here we're going to do increment y, and we're going to compare that to max soft sprites. And if that's not equal, go back to loop. At the same time, we're going to increment x by 2. And then that means this entire thing here can be replaced by these 2 lines. So now we're just using these 2 lines, and we don't need any of this crap here at all. Like that. There we go. Now, it does mean that the update bullets is going to be a little bit different, because now what we've got is, instead of an X and a Y, we've got a screen address. So what we need to do here is a little bit trickier. First of all, our bounds checking is going to fail here. So I'm not too fussed about that. We'll go through that in a minute. But for now, we're just going to move the the system to use this new lookup instead. So same thing applies here. We're going to create a loop with y and with x. I'm going to change this to increase x, increase x, increase y, pair y with max soft sprites, which is not equal loop. Then here what we need to do, again we'll check the char, comma y, and if it's equal we'll skip. But now what we need to do is we need to load the value in a location Sprite lookups plus 0, comma x. Now, no, I'm not using the brackets here because this isn't going to be an indexed lookup. We actually want to change the address in these locations. This is the lower byte of these locations. And so here you can see we're adding soft sprite dx. Now, the x at the moment is in it's in characters across, so we can actually do x and y both with this same thing because we're changing an address here. So we actually don't need dy either. So I'm going to change this to delta. I'm going to change that up here. And now we can just provide a value in here and it will apply that value to the screen address, and we'll be able to do up and down at the same time. We'll need to do a check to see if the value is negative. If it's negative, we'll need to make sure it goes backwards instead of forwards. But essentially, we can use the same value and not have to use multiple values for the delta. We can just use a single because we're using memory delta rather than screen coordinate delta. So where's the add bullet routine? It's going to change that. It's in shoot, isn't it? Here we go. So this just becomes delta. So it's like update bullet. So we're going to add the software sprite lookup, and we're just going to store that back in here. We'll get rid of all of this. We'll do the bounds checking again in a minute. I'll show you how you'd have to do the bounds checking to make this work. And we just do an add 0 here to make sure that if there is a carry from this, then we update it. And there we go. Now the update is quicker as well. So hopefully this just works and it's jamming. Let me just see what I've done wrong here. Probably missed some. It's a lot to kind of change in one go. Okay, draw bullets. Shouldn't need to do the draw bullets anymore because we probably will need to do something to deal with that, but let's just leave that for now. X and Y, it's fine. So add bullet, we come in here. Well, let's run it in the debugger and we can go and have a look at what's going on in the memory space down there and see exactly what's happening. So let's just give it a pause while it's still running and just go and have a look in that location in memory, which is going to be 2, 3, basically 4 onwards. 4, 5, 6, 7 onwards. So these are our locations here. Okay, they look wrong. So there's something not right with the add bullets. That's fine. Let's go and have a look at that. So let's put a breakpoint in screenwrite LSB, comma X. Alright, let's put a breakpoint in here and see what's happening. I think we're just getting the wrong value out here, so okay, so we're trying to add a value in now. The X register should be the Y position, which should be according to this it's 11, which is fine. So if we skip through this table a little bit, that means it's going to grab A8 as our row. We'll add 3 to it, which makes it become... Oh, why is that not actually added 3 to it? Why did that not add 3? Oh, the position was 0. 3 is okay, 0. That's fine. And we store that at the screen lookup, which is this one here. Okay. Oh, wait a minute, I've done something wrong here, that's why. Okay, yeah, so that should be that. Basically, I was not using the index, I was using something else. Thank you for the follow, Pudzol. Welcome to the stream, dude. Let's give that a quick try. Oh, shit, I've got breakpoint in there now, haven't I? Of course. Get rid of that. Okay, we're still getting a jam in there. Let's put the breakpoint back in. Let's go through it again. So basically, I think what's happening is it's not adding the right screen position in here. So you see it runs here, and if I skip it through, so it's added the first bullet in. But if I look at the screen row on here, actually it's correct here. It's 06A8, so that is kind of correct. That's kind of down here somewhere. Let's see what it adds into the next position. 06F8, that seems to be right. And okay, these positions are looking pretty decent. Not seeing anything weird going on yet. Everything looks good. And actually you can see the bullets kind of moving across, these A's moving across the screen. Oh, the problem is, because what's happening now is that when they go off the screen, they're not disappearing. So when they drop down here, they're actually overwriting code. So that's fine. Things are kind of working correctly. So we'll keep the bounds positioning in. So the way you keep the bounds positioning is you restore your soft sprite X and Y, and you just make sure you increment these when you increment the other stuff as well. Push up EK84. Thank you for the follow. I would love to have thought about keeping one of the tender keyboards my faculty threw away 10 years ago. It's the most special item in the Western world. Yeah, some of the old, especially the AT keyboards. If you can get some of the ones, the AT, I think they were called AT. They're like, it's almost like a serial connector. They tend to be quite well sought after because they're just hard to find now. And some of them were really nice because back then mechanical keyboards were the norm. These membrane keyboards are just kind of a cost-saving measure, really. So we're going to keep soft sprite X in, which just means we need to store the soft sprite X value, which we store X in temp2. So all I have to do is do it here, basically. I'll store that at soft sprite X. Right. And so all we have to do is in the update bullets, we can also, in here, we can do soft sprite X, comma, Y, because Y is the one that goes up one at a time. We can do this. Yeah, we'll do it on here. It's fine. And we'll do the same check again. We'll compare if it's 28, 20 if it's less. Here. Store it. If it's not less, then what we will do is we'll load 0 and we'll store that at soft sprite char. Come on. So while we have added an extra little bit in here for the bounds checking, our draw routine is still very, very small. So the actual overhead for that should be a lot less. Still getting a crash though, weirdly. But you can see the overhead is a lot less. Before it was kind of flowing over into here, but now it's not, although we are getting a crash, so we need to figure out what's going on there. That's a really interesting fact. I like that. Yes. And if you shift them all in the same direction as well, that's kind of spooky. No, I wonder if that was that deliberate or was that just a happy coincidence? Because that is kind of spooky. Okay, so just make this a little bit bigger. It's kind of hard to see where the sprites are on here, actually. Oh, what is it that's crashing it? I don't understand what's crashing it. I think it's something is writing into the wrong place at some point. And I don't know why. See when it crashes, I can go and have a look at that memory block and see if there is something really obvious there. So these are our locations. And actually I can see here we've got 2222, which is definitely wrong, and 001C, which is definitely wrong. And then the rest look kind of okay, all the way up to here, which still looks okay. But for some reason this first one looks wrong, and I don't know why. So let's just reload ERG and start Control L. Okay, Control L. It's trying, but it's failing for some reason. Kubrick said it was not deliberate. Okay. It's an interesting fact, though. I've never even known that before. It's kind of cool to know. So I think the software sprites are being added in the right place. I can, if I just turn off the fill screen, it'll just be a bit easier to see them for now. But for some reason, when they go off the screen, they're breaking. As soon as the first one goes off screen, so as soon as we hit the boundary in this one, we're seeing a problem. Wasn't there a Red Dwarf joke based on it? I don't remember a Red Dwarf joke based on it. But I may just be remembering badly, I guess. But I don't recall that at all. Okay. Yeah, as Foray said, you could use BCC to skip this as well. So you could do like this, and then just do increment here instead. The reason I'm doing it like this is just because this delta could go in either direction. So for now, I'm just gonna leave it like this. But yeah, you could do quite a lot to speed up these routines. I'm just trying to work out why it fails. Like if I don't update the bullets, does it just... Yeah, if I don't call update bullets, does it just stay the same? Let's have a look. I think it's just because it goes off screen. I think that's all it is. Yeah, see, everything's fine there. It's just moving up and down. It's only when it goes off the screen here, so it's definitely to do with that. Just put that back in. Let's try reducing this. See if the bullets actually... No, you see, as soon as they finish, they kind of go all over the place. And I think maybe it's that this char is not working properly. So let's check each loop. So we're checking soft sprite char if it's equal with skip. That's correct. Clear at soft sprite char equal with skip. Soft sprite char is equal with skip. Okay, so for some reason, I think when it clears it, it's not actually clearing it properly. This should be clearing it, but it doesn't look like it is. This is working, because you'll notice when I ran this that the sprites only went like 2/3 of the way across the screen, and then they kind of freaked out. So this here should be preventing the sprite from working, because it should be setting 0 for that sprite. But we're not seeing that. We're seeing something a little bit odd. Okay, soft sprite chart. Yeah, this should be fine. I don't know why this isn't working. And it shouldn't matter once it gets to this point, because soft sprite has failed. So when it goes to draw the next bullet, it gets into here. It says, what is our soft sprite? Is it 0? Yes, it is. Jump to skip, and it skips over. Why is this not working? Okay. Oh, is that what he said? So if I know every intelligent person know how it's derived from heuristic algorithm. Okay. I want to kind of hurry up this bit because I do want to show how it blends in with the background in a minute, which is a whole thing. I might have to do this over two streams if this takes too long. The reason I want to do this optimization, because I think it is a huge optimization, and you'll get way more sprites on screen if you use this optimization. So one of the problems with this system is when we do the clear bullets, it's just reading the value. When we draw the bullets, it just reads what's underneath in the position where we want to draw the bullet. So the problem is if you've got two streams of bullets that crop. So if you've got a player that's shooting at an enemy and the enemy can shoot back, you will get the occasional situation where it tries to draw a bullet over a bullet, and of course that means that the original character it tries to remember is a bullet, which means it will cause bullets to stick on the screen, which is another one of the problems that you see in Turrican quite a lot. So the technique for that is what you do is you if you're using static screens, so if you're using like a flick screen game, you will have basically a copy of that screen, like a double buffer of that screen somewhere else. I think we use that in the Saturday game. I think we do have a screen buffer where we copy things. And basically you just use that screen as an kind of blemished version of the screen. You never draw anything else to it, you just draw the map to it, and then when you want to record what's underneath the sprite that you're about to draw, you go and grab it from that buffer instead of from the actual screen. It shouldn't matter, because what we're doing is we're setting so to answer Foro's question there, did you make sure when adding a bullet over a previous bullet is resetting the sprite X properly? Yeah, so if you add a new bullet, it should add the X and the new position and everything. Oh, maybe it is to do with the limit. Let's have a look. Let's set the limit to 2, see if it crashes quicker. Yes, it does crash quicker. Okay, so Foro might be onto something there. Are we hitting the bullet limit? I don't think we're hitting the bullet limit. See how quickly it crashes though. I don't think we're hitting the bullet limit. I don't think it's that. It's definitely to do with where they go off screen, I think. I should maybe not done this optimization, but it's fine. It's fine. It's a good thing to do, I think. I was thinking before the stream I should definitely show it. Okay, so this is just adding the new screen position. This is just updating the screen position. This is taking our X position, adding 1 to it, comparing it with 18 or 24, in decimal. If it's less than that, it's coming here and it's just storing it. Otherwise, it's going to store a 0 as our sprite char. And then this routine is always checking. These loops are always checking the sprite chart. It's equal to 0, it skips. And it's the same in this one. Let me put a little marker on here. Just to see if it is doing something really when it gets to that point. So, okay. So it's crashed at that point. Oh wait, DF. Okay, so really looking forward to this Saturday stream, by the way, guys. It's going to be freaking awesome. We've got so many good... Okay, no, it looks fine. We've got so many good new sprites to put in the game. I'm really looking forward. It's going to be great. But yeah, you can see here. That's fine. And then weirdly it just goes all screwy, like 810C. Why is it 810C here? It really should not be 810C. In fact, that looks like it's just storing the character directly in that location. Are we doing something wrong with the update? Are we doing something wrong here? No. This looks perfectly fine. Soft sprite delta. Make sure that delta is correct. Should only ever be 1. Soft sprite delta, yeah. Which is this thing here. Only when we add bullets. Okay, I'm going to get rid of that from there. Just going to call it here. Just want to see if I just shoot one set of bullets, does it fail? No. I mean, it kind of draws kind of wrong, but it does work. Actually, the second bullet seems to be wrong for some reason. We're only seeing one bullet. See that? You only see one, not two. It should be showing two. So that's our Y position. That's correct. This is our character. That's correct. Make sure it's not. No, it still only shows one. We should see two. You can see it's trying to draw two because it's drawing these stupid characters here. Because it's not storing the original data. And the reason that's happening is because when we've actually set these, when we add these positions here, the first thing we should do is we should then look up this sprite data and store the original character as well. But I need to get the rest of it working first. Yeah, it does loop over the same sparse rate no matter how full it is, but the character should be off screen by that time, so... No, there is no bullet count, so we just have an index that goes through the list. So what it will do, it will go through the list, and then when it gets to the end, it just starts again at the beginning. But the problem is, you just need to... Well, it's not a problem, you just need to make sure that the maximum number of sprites is high enough so that all the sprites will... If you fired 32 sprites, one after another, that they will all die before you get back to the beginning of the loop again. Which we're doing. I mean, we're never seeing all 32 on screen at one time. We're just seeing one. But there's some fundamental problems. Like when we shoot here, we should be seeing two bullets, but we're only seeing one. Weirdly, I don't know why. Let's just move this over just to make sure. It's not something to do with it. Yeah, okay, I'm going to slow that down and just do it again. So there's one there, but it's not moving, it's not updating for some reason. which makes me think the update routine is wrong. I'm convinced the update routine is wrong for some reason. Increase X, increase X. Can fly. Increase Y, compare Y, subscribe, go back to yeah. And we're not using X and Y outside of these things. Ha 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 ha. It's that. It's that one little line there. I was using the wrong index to add the delta, so I was actually adding something completely different. There you go. So it was working, I just did one thing wrong. Now I need to go and restore everything that I turned off. Yeah, there we go. And you can see it's using a lot less. I mean, it will use more if I expand it out a little bit. Yeah, 23 degrees. It's 29.6 in here right now, which is just, I mean, it's ridiculous. Okay, so let's set our border up a little bit. So obviously you would change the update function to suit your needs. For a standard shooter, you know, a standard scrolling shooter, this is going to be enough. This is going to cover most of your needs. And you can see that's not too bad. It's firing quite a lot of bullets, and it's not too bad. What I'm going to do now, I'm going to fix. You can see this kind of space that it's creating here, so I'm going to fix that. Show you how to do that. Then I'm going to show you how to make the bullets kind of spread out into slightly different patterns. Actually, do I want to do that? Actually, no, I don't think we need to do that. I think you can kind of figure that out from the update. And it's just going to take a bit more time to do so. So basically, if you want to change the pattern of these, at the moment they're just shooting across in one go. If you want to change that, it's just a matter of changing your delta and then changing this update. So the first thing you would do in here is check if it was a negative number or a positive number, and just do two different things here. If let's just do it. Let's just do it. Fuck it. Okay, so let's call it negative, and this will be positive. I'm gonna call this posneg done. Why not? The only problem with this is we might need to add Y bounds checking on here as well. Which is probably why I shouldn't have done this, but never mind. So if it's negative, we need to... how do I do this now? Think about this. If I add FF, it is going to carry, so if it... Oh, God, I can never do this negative addition thing. And I know I've done this many times before. If it's FF, then this needs to be -1. So, actually, can we use we can use temp here? So, yeah, fuck it, we'll do it this way. Okay, so if it is negative, we'll come to here. In which case, we're going to ignore it with F. We're going to add 1 to it. Fuck it. There we go. And now I can just do some temp like that. Cool. Right, so again, I've got no bounds checking on this, so this is probably going to go horribly wrong when I do this. But what I'm going to try and do now is the second bullet. I'm going to play around with some stuff in here. So delta, I'm going to make it 29 for this one, and that should make a kind of diagonal shoot. Yeah, you can see it goes horribly wrong. And that's because we've got a Y position that we also need to check as well. So let's come back up to here, add bullet. And restore the Y position as well. Oh, actually, yeah, this is not going to work. No, I'm going to undo this because I've made this a little bit awkward. You will have to kind of customize this for your own needs, because what I'm doing is I'm doing my bounds checking by explicitly checking +1 on the X. So I'm going to remove that because it's going to take too long, and I want to get into the merging with the background stuff, because I think that's more important than this. This just comes down to you've got an X and a Y, you've got a screen address. How do you update all those values? So I'm not going to mess around with that because it's just going to cause havoc if I do that. So I'm just going to leave it like that, and instead we'll deal with the other side of it, which is going to be merging with the background sprites, merging with the background tiles. Oh, and clearing this bit. So let's do the clear first. So you can see it shouldn't be making a space here at all. The reason it's making a space is just because we're not setting our original character. So as soon as we add a bullet, we should be grabbing the original sprite from there. So so we've got the Y register here. We can use the X register. So what I'm going to do is I'm going to transfer Y to the accumulator. I'm going to double it again by shifting it to the left, and then transfer it to the X register. And then I can load accumulator with soft sprite lookups, $X, and store that in soft sprite original char, $Y. That should prevent that from happening. It's just because the very first frame, it doesn't record what's underneath it, whereas that is doing now. So cool. Initiate havoc. Yeah, I don't want to overcomplicate things. It's already a little bit more complicated than it probably should be because of the optimization, but I think it's an important optimization to take into account. And you can see this is doing. I mean, let's just try and pause it. How do you actually pause in this? No. There we go. 4, 8, 9. So that's 18. Okay. 3, 4, 5, 6, 7, 8, 9. Yeah, it seems to be doing 6, 7, 8, 9, 18 sprites at a time there. Maybe 20 at a push if I catch it with just the right frame. Like that. First 20 sprites. So let me add another row in. Sod it. Why not? Let's add another row in. Just so we can see. So let's just increase that by 1. Yep. And let's make them all different characters as well. So it's the ABC gun. There you go. So this is doing up to 30 sprites now at any one time, and it's running. I mean, it's using quite a lot of raster time, but it's still happening all off screen, so that's pretty good. All right, I'm going to take a quick break, and then when I come back, we're going to switch this over to. Actually, I'll probably use the Saturday stream character set because it's there, it's already done, and I'll show you how to merge things into the background so you don't get characters completely disappearing, because most of the time your bullets are not going to be huge full 8x8 pixels. In fact, in most shoot 'em up games it's just a line of pixels or 2 lines of pixels, which means if you're firing over quite a detailed background, you're going to have quite a huge chunk of blank space with a bullet in the middle of it. You're going to see the character be deleted and replaced with a bullet. So by merging it with the background, you slow things down a hell of a lot. I'll tell you that now, and you'll see that when we do this. But you do get rid of that kind of. It's not clash; it's more of a kind of replacement of the character. You get like a blank space where your white space around your bullet is. So that's. I'm going through that wine, but this is really good wine. I definitely recommend this one. It's called the Ned, which is a hill, I believe. Well, it is looking at the map anyway. But it's really nice. What is this? This just sounds like sound effects. Oh no, it's music. Okay. Alright, I'll be back in 2 or 3 minutes. Alright, be right back, guys. And I'm back. So, hopefully you've managed to follow along steps. So I know it's been a bit, some of it's probably been a bit haphazard because of the optimization, but hopefully the principles of it make sense. And really the next bit is just kind of just enhancing it slightly. So what we'll do is we'll take the map that we've got, the new graphic stuff, so this, and if I get rid of the tiles, how do I do that? Okay, so I just need to export character set. The Ned Pinot is good as well. Yeah, Pinot Grigio, or the Pinot Noir. I imagine it's a white. I can't imagine many good reds as well. Oh, it is a red. Okay. So all we need to do now is we need to set some graphics modes up here. We don't need this fill screen anymore. We'll get rid of this because it's going to be automatically filled by the process. In fact, we got rid of it there anyway. We need to set the screen and the spelt colors wrong. No, I think you spelt colors wrong. I just noticed your name is Kiwi Jim as well. Is that why you know these wines? Are you actually from New Zealand? Yeah, hopefully I've explained the principle well, even if I haven't implemented it very well myself. You are, but you live in London. Okay, cool. Are you a fan of the Concords? So that's hands down the best thing to ever come out of New Zealand. Is Jermaine, Clement, and Brett. Oh shit, I forgot his last name. I can't remember his last name, but yeah, the Flight of the Conchords. Absolutely amazing. Even upside down people can spell colour. I'm right, you're all wrong. Yes, definitely. What we do in the shadows is amazing. Absolutely amazing. Oh yeah, Peter Jackson as well, yeah. I still think Flight of the Conchords is better than Peter Jackson though, to be honest. That's just my personal opinion though. I'm not a big fan of like Jackson's films. I think they're good films. They're just not my kind of films. So. Okay, what was I doing? Oh yes, so we're going to set the memory address for the bank for the Vic, which I can't remember. It's going to be it's definitely D018, but I can't remember what the exact values are going to be. So let's go and have a look. So I'm going to use this D018. Oh my god, that's bright. Let's do this quickly. So point to screen memory. So screen memory is at 2800. So 1010. And then character RAM is at 2000. So 100. Then anything we want on the end. So that D018. So this should, in theory, give us a screen. Okay, cool. Now, I don't know why we're not. Oh, we're not seeing the characters now because I actually haven't set them up here. Screen RAM is now at 2800, and I'm going to fill the last 3 rows because the screen actually only takes 22 rows. So I'm going to fill the last 3 rows with 0. Cool. You can see we've got that moving over. Now you probably, with something this big, with the characters this big, you can see it's not really making a huge problem as it goes over things. I mean, if I pause it, you can kind of see there is a bit of blanking as it goes over. Let's turn multicolor mode on and just make sure that we get the colors right and everything. So multicolor mode is bit 4 of D016. So we're going to load D016 and we're going to turn on bit 4. So we just need to OR it with bit 4. And then we'll set some colors as well. So let's set the border to black and set the background to blue. And then our multicolors are, I think the multicolors are black as well. So, and the other multicolor is green, I think. So let's just try that, see what it's at. I probably got those 2 colors the wrong way around. I almost always get them the wrong way around the first time. Yep, thought so. So let's switch those around. So, and then we just need to do a pass on the screen to set the colors. So we'll do that quickly now. So we'll make a new routine called color screen. Stick that here. And this is just going to go through the entire screen, and it's going to grab a value at screen RAM, and it's going to transfer that to the Y register. Then it's going to load colors from a Y, and it's going to store that at D100 on an X. And let's do this with the kick loops to make it a bit easier. Oops. I equals 0, I is less than 4, I equals plus. This is just going to recreate this code 4 times, maybe without me having to actually recreate it 4 times. And this will be plus 100 times I. Likewise, this will be plus 100 times I. Yes, that right. So that should give us a coloured screen now as well, which it has not done. Okay. Oh, helps if you actually do a loop and not just one. One character on the screen. There we go. Interestingly, it's done. Oh, was the other color red? Maybe the other color was red. It's not green, red. There we go. So what I'm going to do very quickly is I'm going to create a little bullet sprite, and you'll see the problem. So if I load up our character setting here, so I'm going to use, let's use this one here. So let's fill it with transparency first, and then we'll make our char color white like so, and we'll just draw, oops, we'll just draw a bullet like that. So this is typically what you might see as a bullet. Export character set. Yeah, char soldier. Oh, I actually need to make it use the right character. So that is character number 96. So in here, when I add the characters here, these need to be 6. So that's 96 in hex. I think that's 60 hex. And we're gonna reduce it to just one stream of bullets, and the reason we're going to do that is because it's going to take a lot of processing power to do what we're about to do. So there you go. So a couple of things that are an issue here. Firstly, the color RAM is not being changed for the bullets. So what's happening is every time it draws a bullet, it draws it with whatever color RAM is underneath. Now there's two ways to get around this. One way is to use a multicolor for your bullets, which is definitely the easiest way, and I think that's the way we're going to do it for now on this. If you wanted to use a character color for your bullets, which is probably quite likely, because I mean I would like to use white for these bullets, but it's looking like white is not one of the options. Red and black are our two options, so I'm going to go for red as our bullet color and make it a multicolor, in which case it won't matter. But if you wanted to use white, what you would have to do is you would also have to store, as well as your these lookups here, you would also have to store color lookups as well, and you would have to store the original no, you wouldn't have to store the original color, but you would have to write the new colors. You'd have to write that whenever you draw the bullet, you'd have to draw it in white in the using this new table. So you'd have another table down here which would be like color lookups like that. And you do the same thing anytime you increment one of these. You would increment these at the same time, and then when you put the character back, what you would do is you would just look up in the color table, your character attributes table, and put that back, put the color back as it was. You could also store the original color if you wanted to, but you may as well just look it up in the table. It's not going to change. So but what we're going to do is we're going to just to make this simpler, we're going to use a multicolor character to make this red instead. This is one of the reasons why proper color choice for your multicolors is really important, especially if you're using soft sprites. This is why we've had issues with this game. This is why we've thought about this a lot, and I think this is probably going to be the 4th or 5th time I've changed the colors on this. So but we're going to have to do some. So the soft sprite system we use in the game on Saturday is this, but on steroids. Basically, it uses multi-directional sprites that can move 2 pixels at a time. So in fact, they can move 2 pixels across and they can move 1 pixel down. So but you can see as the sprites move over this area here, you see the black problem that we've got here. We've got a black background, and the sprites that go over are putting holes in it. So that's what we're going to do now. We're going to change the routine for these to actually not blank these out. So this means that what you need to do is you need to create a new character in the font for every bullet that you fire. So what that means is we've got 32 sprites, so you pick a start point. So you can see in here actually I've kind of numbered where they start. I think this is where they start, and then there's a dot for each block. So we'll use this kind of rough location. It really doesn't matter where we use because we're going to overwrite it as long as it's not being used on the screen. So we're using 32 characters, so I'm going to do it from here because it's in the middle of the character set. In fact, I'm just going to blank all that out because I don't need it at the moment. As long as I don't save this file, we should be fine. I'll export that character set. There we go. Thanks for the follow, Rooty Welcome to the stream. Hope you're doing well, dude. Okay, so what that means now is when we draw a character to the screen, instead of drawing the character number that we should have, we need to draw a character number based on our offset. So what we're going to do is we're going to create in here, we'll do a label. So this is our soft sprite font start, we'll call it. And we set that to 128, so that's character number 128 here, this one here. And so what we're going to do is we're going to take our draw routine. See, we're loading the sprite char here. Instead of doing that, what we're going to do is we're going to load the accumulator with soft sprite font start. But we need to add the index here. So the easiest way to do this is going to be transfer the Y to the accumulator, clear the carry flag, God, I've been drinking, and add our soft sprite font start. And now when we do this, we should just see loads of blank squares. In fact, what I'm going to do, I should probably, if I undo this, yeah, they're numbered here, so I'm just going to, oops. Going to keep that in actually and do it like this. So we're going to, so what we should see now is when we shoot, we'll see these numbers in sequence. I might have to slow it down so you can actually see it happening, but which you kind of do half of the time. So we need to figure out why it's only doing it half the time. So at 128, it is at 128 indeed. Okay. Now it's going to show multicolor characters because that's what we've asked it to do. And these are all multicolor kind of locations on the screen. I don't know why it's not loading the right character. Let me have a look. So transfer Y. Okay, we don't need that. We do need to add the soft sprite. Oh, that needs to be hashed. There we go. Good night, Sinlow. Thank you for joining, dude. There we go. So it's kind of hard to see because it's using multicolor mode, but you can see now these sprites as they move across the screen. 7, 8, 9, A, B, C, D, E, and if I pause, you know, the same sprite is the same character in the font is being used every time. So this is where the fun comes in. So once you've got this value here, you also need to have a font address as well, and this will be your font address, which is 2800 plus the font start. Actually, it's not 2800, it's 2000, sorry. Plus the font start times 8. And what this is basically is the very first address in memory of the first sprite. And we're going to use this to change the data in here. Now, this is where it gets a little bit tricky, because what you need to do is when you grab the original sprite, which we're doing here, you actually need to update your character in your font. So the way I'm going to do this is I'm going to have a routine. So we're going to jump to grab character copy, grab char copy, we'll call it. And what this is going to do, the accumulator now contains as char to copy. So the accumulator contains the character that we need to copy. So that's the character that originally we were storing in the original char. But what we're now going to do is we're going to, instead of just storing the number that points to that, we're going to actually copy the 8 bytes from that character into a new location. And so we're going to need something in 0 page, which I'm going to call font copy. Oops, so I'll do that there. It should be here. And this is just going to be a little 0 page lookup. It's just going to make this a little bit easier. This just needs to be a word. We're going to need font copy source and font copy destination. I really wish I had my little smoky thing. I don't know where that's gone. I don't know what I've done with that. I need to smoke. Don't know. Oh well. Fine. So be it. Okay, so first of all, let's just have a quick look at what we can and can't bash, which registers can and can't be bashed, so we know what to restore. So grab char copies. So X is, well, it kind of looks like we need them all because we're using X, we're using Y here as well. So probably anything we use other than the accumulator, we need to make sure we put back. So here, the accumulator has the char to copy. So what we need to do, first of all, is we need to take that value, which is going to be from 0 to 256, and we need to shift it, multiply it by 8, so we get the font address, basically. So the easiest way to do this is, first of all, store this in our font source, font copy source plus 0, and then load the accumulator with 0, and store that in font copy source plus 1. So now we have a word which is we have a 16-byte value, a 16-bit value, which is the char to copy. So now we can multiply this by 8. So the way we do this is we shift this value to the left, and then we roll the second value to the left. And that means if any bit on the end of this overflows, it gets put into the next one. And that's times by 2, that's times by 4, that's times by 8. So you can see why this is slow, because we have to do this every time. Every time we want to draw a character in a new place, we have to do this. Times 8. Then we have to add the font base address. And our font base address is 2000. We only have to add it to the upper bit here, so we're just going to load that one, clear the carry bit, and we're going to add 20. In fact, the carry bit should be clear here, I think. Let me think. Roll. Yeah, it should be clear. So we can just add 20 and store it. So now we've got our source address, and we haven't used any of the other registers. Next job is to, based on the Y register, we need to work out where to copy it to. So we're going to do the same thing again. But we're going to do this with the Y register this time. And this will be destination. Now you could probably make a table to make this a little bit quicker. which if you're going to do a huge amount of software sprites, I would definitely recommend using a table for this. So you would create a table that has all the kind of font lookup, or all the font addresses for each of the characters. So you would just look up in a table each one of those and do it. But I'm showing you this way because this is actually what we're doing. So yeah, I mean, we could pre-compute corresponding chars. Yes, you could. So the other way you could do this as well, of course, is if you only use half of the char set, or just less than half of the char set. So if you imagine if you've got 32 bullets, and then the remaining characters that are left, so you have 32 for bullets, then the remaining characters that are left, which is 224. If you only use half of them for the background, 112, then you can use the other 112 to have the bullets over the top of them, and then you just basically show whichever one. In fact, you wouldn't need the 32 separate things, so that would be another way of doing it. But that basically halves your character set. I would definitely recommend using a table for this. Maybe we'll do that as a table, but I just want to show you how this works, and then maybe we can try and optimize it by using a table. So okay. Okay, so we've got a source and we've got a destination. The destination, we need to add the font destination address. And the destination address is going to be 2 bytes, and it is basically going to be this address here. So this needs to be, oh my god. Cool, and there we've got the upper. So we've got the source and we've got the destination. It's destinations, which means now we can do the really simple thing of, we might as well do this loop backwards, of copying this sprite to the new location, and you'll see what happens when we do this. What you should see is no change. You should see nothing happen at all, and that will prove that the characters being drawn are the original ones that were there before, but copies of. But we'll go and take a look at it in the debugger, and you'll be able to see. So we should be able to load font, copy source, y, install that at font, copy destination, y, decrease y as long as y is positive, go back, RTS. So that's quite a lot, and you can imagine this is not going to be quick, which is why really, if you're going to do a lot of sprites, a lot of software sprites, you're better off not doing this at all. Turrican doesn't do this. Most games don't do this, but there are games that do it, and it is worth doing if you can get away with it. If you have the processing power to do this, then definitely do it. If you don't have the power left, the frame time, the raster time to do this, then definitely don't do this. Okay, so we need to make sure that when we draw a bullet, instead of doing this here, we're going to do this draw copy right there, grab the copy. And what we should see is it's going to take a lot more time. In fact, it's completely crashed, so something has gone wrong. Let's put a little breakpoint in here and just see what the values are we get out of this. Okay, so font copy destination, so 7 and 9. So it's saying we should be getting from 2140 and copying to 2400. So that seems to be fine. And then the next time 20 to, yep, so that seems fine. Okay, these are kind of looking all right. So I'm not sure why it's suddenly taking loads of processing time. And in fact, it's reaching a point where it's just going haywire, and we're getting, yeah, we're getting some. Oh, actually, no, this Sure, what's going on there? Okay. Oh, I know why. It's because of the Y register here. We're using the Y register here. So what we need to do is transfer the Y to the accumulator, push it onto the stack before we use it, and then we can pull it and transfer it back. That's because we're using Y in the list. That's why. Okay, for some reason it's blanking stuff out. But you can see it's not crashing out, but you can see how much extra processing it's taken, even though we're only using one row of characters. So, oh why, my god. Hey, Lucky Force, yeah, using Sublime Text 3 for this. I will say it though, if you are kind of used to IDEs and you don't mind kind of trying to figure out a different IDE, use Visual Studio Code. I think you'll probably enjoy the tooling around Visual Studio Code better than you will with Sublime. It's just I use Sublime because it's what I used when I started, and I've just never changed. So, all right, let's run this in the debugger. I just want to see what's going on in the character set. So you can see it's trying to draw something, but it's just blanking the screen out. But you can see we're going through. Everything's looking kind of good here. The memory addresses that it's looking up seem to be correct. We're not getting any crashes. Let's go and have a look at the font. If I can remember which button it is for font. Okay, so interestingly, the font isn't actually changing. We're just seeing blanks in the font. So I need to check that this is actually working correctly, because this doesn't seem to be working correctly. Node, font source Y, store, copy, destination Y. That should be right. That should be right. So let's put a breakpoint in and let's step through it a little bit. Let's see what's actually going on here. So let's put a breakpoint here and see what happens when we try and copy that character. We're not getting any crashes yet. Sometimes that's enough for people, right? Okay, so we've got a breakpoint here. Our memory is set up to say we need to copy from 2140 to 2400. So if I go and have a look in the font, 2140 is going to be this is 32 in a row. So this is 2100, 2108. Okay, so it's copying blank space, which is fine. So we should see a blank space copy to this location here when I press start. Why am I not seeing? Oh yeah, I am seeing two, so it's repeated. Okay, there we go, and we see a blank space. Okay, cool. So that kind of worked. The problem is when it reaches one that isn't a blank space, it's not working for some reason. So there, for instance, it should have copied something different, and it didn't. Again, though, it's saying 2140, 2400, 2140, 2408, 2140, 2400. Oh, okay. Why is it not reading that value properly? Okay, let's stop the update and let's just get it drawing one character. On screen at the right position. So if we have a look here, if we move it right to the edge of the screen, we should be able to see what's going on. So let's change X to 0. Accumulator actually doesn't matter anymore now. Maybe do it with debugger. Okay, so we're going to be drawing somewhere around here. And it's saying we need to copy 2048. So if we have a look at 2048, that's definitely going to be something. So, but what we're getting is this for some reason. Okay. And now it's saying 200. Why is it saying 200? Oh, I think we're drawing the wrong thing back. That's all. Okay. Right. I'm gonna just comment out because I need that. So when we draw the bullet, we need to grab the character copy. We do still need to store that original one there. That's the problem, because we do need to draw it back. We do have to keep the original copy. That's the mistake I've made there. So there we go. Cool, that's working. The reason I know it's working is because nothing is happening. And that's what I want. That means it's drawing the right characters in the right places. Let's stick the update on and move the shoot back into this position. Cool, there you go. So this is actually filling the screen with characters, and if we go and look at this in the debugger, you'll see that that's actually what it's doing. Well, you'll see it in the character set, but you won't see it on screen. But the characters across here are actually changing. And you can see here that they're changing in the font here. So this is where the cool thing comes in. So there's two ways of doing the merging of the characters, and it depends on how you've set out your bullet sprite. So we've done the most simple bullet sprite here. So we'll use this example first, and then we'll change the bullet sprite to be something a little bit different, and we'll show you how that works. So with this bullet, you need to do this on a kind of a case-by-case basis. So in this case, what we've got is we've got 3 lines that should stay exactly the same. So whatever was behind them should stay the same. And then 2 lines that need to be replaced, and then 3 lines that should stay the same again. So what we can do is when we do the grab character, so in here, where it is, in this loop here, instead of doing it like this, we can just do it kind of manually, one step at a time. So we're basically going to unroll this loop. So we'll start with the top line. And that is exactly what it needs to do. And then with the next line, exactly the same again. So we just increase the Y, because we need 3 lines that are what were behind it. And at the end, we need 3 lines. So there we go. So I need to let me put this back before I forget. But here, we need to put the bullet in. So we could, in theory, copy the data from the bullet directly into here. But if we look at our bullet, it's quite simple, right? It's just a row of characters. So actually what we can do here, instead of let's indent it. Instead of actually trying to copy any character whatsoever, we can just do this in code. So we can just load a value in here and store it. I don't think FF is going to be right, but let's just try it anyway. And there we go. So we've got bullets, but you can see it's using the character color here. So we need to change that to something like AA or whatever it is to get the AA. Yeah. No, it's going to be the other one, isn't it? It's going to be 5.5. There we go. And you can see now, if I pause it here, we've actually got, it's actually merging properly with the background now. Now, obviously, that's going to be very case dependent, and your bullets might not always look like this. So the other thing you can do instead of doing this is you could say, okay, I know where the bullet is in memory, right? So our bullet is here at 96, which is actually 300. And so that means these bytes are 2303, 2304. So you could change this to 2303, 2304. And now if I If I run that, I should get exactly the same thing. Obviously that takes a little bit more time, so this takes 4 cycles as opposed to immediate mode. So if I was to do this takes 2 cycles. If I was to do this, it takes 4 cycles. So this takes a little bit longer, but now what you can do is you can actually change that those 2 lines to be, I don't know, something like this, for instance. And you know that if you change it in here, as long as you just change these 2 lines and nothing else. Oh, I know this tune. Ocean Loader, that's why. Yeah, everybody knows that. And there you go, so you can see it mixing those in. However, that's not always going to cut it. So let's go for the most complicated example we can think of now. So what you need to do for a complicated example, so let's say we've got something like this, right? This is now using 6 lines. Actually, let's make it checkered because I like that checkered approach. Oh my god, I've made the right mess of that. Okay. Oh god. Okay, so that's quite a complicated sprite in terms of, you know, drawing it to the screen. Now we could do the same again. We could just draw, you know, copy the first line, copy the second line. But then when you get to this line here, we've got gaps here. So if we just copied this data directly in, we'd still have gaps here and here. So what you do is you create a mask. So in the sprite, and the one directly after it, so we'll do it here, fill it with transparency, and then basically you do an inverse of this but in char color. So you grab a char color, oops, and you draw an inverse copy of it. And now this is a mask. So what I mean by a mask is if you were to fill this with char color and then cut this shape out of it, this is what you would get. Doesn't really matter what color you do it in, because you're not actually going to see it. We're just going to use this data to cut stuff out. So I'm going to save this character set out now. And first of all, I'm going to show you without the mask, and I'll show you with the mask. So without the mask, what we can do is we can just copy 6 lines, same way as we did before, where we would just do something like this. And we still use the other lines the same, but you'll see when we do this now, we will we'll still get some cutouts. So you see we're not getting the full cutouts. So the top 2 lines, the top line and the bottom line, we have actually copied as a whole, because we know that our sprite only takes these 6 rows. But it's still not good enough because we still have these gaps here. Always use a mask, yeah. And yeah, this is a lesson to keep your bullet graphics simple. The simpler your graphics are, the less you have to do at this point. So what I'm going to do is I'm going to do this with, I'm going to use a kick loop for this, just because I don't want to have to copy this code loads of times manually. So we need to do 6 lines. So we're going to set our loop up to do 6 lines. And the first thing we need to do is increment y. And the end result is we're going to store our value there. And that's basically what we need to do. So the way this works is you first of all you take the information from your source, but instead of just copying it directly to the destination, what you now need to do is you need to apply the mask. So you use and our mask is going to be so our character was at 2300, so our mask is actually going to be at 2308 with 1 line down, so it's 2309 plus I. So that is going to take each line, actually that's fine, it's going to take each line of this mask one at a time, and it's going to AND the original data with that and store it here. So if I just run that now, what you should see is you should see a bullet-shaped hole in the scenery. If this has worked. I might have the colour wrong because I do seem to remember it might be sprites that are a little bit different, but so can you see that? We've now got a bullet-shaped hole in the scenery. So it's merging the stuff in the original stuff, but it's leaving a gap for our new data, and that's just basically we just pour that data in. So why am I using a mask like this? Why am I not just drawing that stuff over the top? And I'll show you why we don't do that in a second. So this is the correct way to do it. You and the mask, and then you ore your data in. And you can see there we go. It's nice and neatly, superimposed over the background without any cutouts. But you can see it's quite expensive. I mean, we're drawing 10 sprites here. 1, 2, 3, 4, 5. Yeah, 10 sprites, and it's using all this processing time. Like I say, you can probably replace a lot of this with tables. That might speed it up a little bit. We might have a go at doing that in a minute. Although it's getting on a little bit actually, so probably not. Although I've got wine left, so yeah, maybe. So you do have to kind of tweak these routines a little bit. So why do we need to use the mask? Well, this is what happens if you don't use the mask. So if you just take the data and just superimpose your stuff over the top of it, what you get is some weird color stuff going on, as you can see there. And the reason this happens is because what you're doing is you're taking a multicolor character. So a line in a multicolor character can look like this, and that's a line of 4 pixels, all the same color, the color 1, 0. And then your bullet might be something like this, a line of 4 pixels where your color is 01. But when you all those 3 together, what you get is a line of 4 pixels where the colors are all 1, 1. So multicolor mode means that you can't just merge these two on top of each other. If you use high-res mode, you can get away with this. But obviously in high-res mode, you probably won't want to merge into the background anyway, because you won't see your bullets. So you won't see your bullets when they're over the background, or they'll be very hard to see anyway. So this is why we have to use and. And what and does here is, so if you imagine this is our bullet, what and does is it basically, the mask in this case would be this. So this is our background character, this is our bullet, and this is our mask. So first of all, we and these two together, and so the background now becomes 1, 0, 0, 0, 0, 0, 1, 0, because we've applied this mask to it. And then when you ore these values in, it fills in these gaps here with 0, 1, 0, 1. And so you get the correct kind of merge of the two. Yes, yeah, you can as well. So yeah, that's a good point. So if we wanted to create a little kind of background color outline around things as they go over stuff, if we change the mask in here, let's change it to this, like that. And then change our sprite to be much smaller, like that. So yeah, you can play around with the masks to do some pretty cool stuff. Try to spot that character set now. So what this is going to do is when it cuts the mask out, it's going to cut a bigger hole than our character. So if you imagine taking this character and pasting it into here, can I paste it in here? No. It's going to basically paste it like that. With our thing, so you will see like a blue outline around everything as it passes through things. So let's demonstrate that now. Put the hand back in, and this is quite common. This is a good thing for high-res stuff. Yeah, so 1-bit stuff. As I was saying, you would find it hard to see your sprite if you were using high-res, but if you use, as Andy rightfully says, if you use the mask to create an outline around things, then you will always get a background, you'll always get a cutout around your items. So good night, Emma. I'm kind of tempted. I think I might call it at 12:30. I'm tempted to play an hour of Last of Us. Why not, eh? I need to finish my wine anyway, so... So yeah, I mean, as Andy says, it does look better on one bit of stuff, but you can see there we've got a nice, neat cutout. So if you did have some clashes with colours, this would be one way of dealing with that. But for multicolour, you can get away with just a mask like this, and it will work perfectly fine. Do not want to save that. Save that. But yeah, that's pretty much it. I think that pretty much covers it. So the only thing I would say is if you do want to have bullets going in different directions, then you need to kind of change the way that the bounds checking works. So you would need to include an X and a Y. You need to make sure the X and Y get updated at the right time, and that the screen updates happen. The screen position updates happen correctly. If you've got bullets that can cross paths, so say, for instance, we've got in the Saturday game, we've got two players that can fire bullets and they can cross each other, then have a copy of the screen data somewhere else. So if you're using static screens, that copy of the screen data would just be a static copy of the screen. You never draw anything to it. You just draw the map to it once whenever the map changes, and use that for grabbing and restoring the character. If you're using double buffering and you're using a scroller, things get a little bit more complicated. You can, if you're clever, you can use the currently unused buffer to grab the character, but then you have to grab an offset from it. You have to know which way you've scrolled, and you end up with problems at the edges of the screen. And this is a problem that Turrican has, is sometimes it gets confused with the double buffer, and I think the timings screw up and it basically freezes one of the characters. One of the bullets gets copied into the new buffer, because what you should be doing is whenever you do double buffering, is just before you copy the data from one buffer to the other and shift it, you need to make sure there's no bullets on the screen. And I think in Turrican there's a bug where occasionally the timing of the bullet removal from the screen and the copy of the double buffer, they cross over, they overlap slightly, and you get a couple of bullets stuck on the screen. It only tends to happen when there's a lot of stuff going on, but it does happen now and again. And it's quite jarring to see a bullet just hang in the middle of the screen. Likewise, if you reach the maximum number of bullets, you will see it as well. So if we've got 10 bullets here, if I reduce the maximum number of bullets to 8, you should see the same effect happen. Let's go to the top. You should see bullets get stuck on the screen as... There you go, you can see them. And that's just because we're basically reusing the loop all the time. So when it gets to the end of the loop, and it starts to redraw again, the sprite that was currently being used is now basically what's called orphaning. It's when you basically drop a reference to something without cleaning it up. So that's what's happening here. We're dropping the reference to the sprite, but we're not cleaning the sprite up behind us. So what you would normally do to combat this is when you go to set a new sprite up, if the sprite that you're trying to set up is already active, then you will first remove that sprite and then draw the next sprite in its place. But generally, you can get away with just having a larger number of sprites on the screen. Because most games that use software sprites, the sprites move off the screen. So, but yeah, I mean that's pretty much it. I think this can be optimized a little bit further. I'm not going to go into it now. I think I'm going to go for a smoke now, and then I'm gonna finish my wine off and have an hour on The Last of Us, I think. Because I'm really enjoying that game and I want to get through it. And I know on Saturday I'm going to be playing Tempest a lot, so I'm dying to play that. I want to save it for the stream. So I will upload this code before I go to bed. In the usual place. I'll post a link in my Discord after the stream. Thank you for those who are going to leave now, who don't want to see Last of Us spoilers and such. Thank you for coming along. I'll be back in 5 minutes, and when I come back, we'll do some Last of Us. All right, be right back, guys.